In this unit, we're looking at ways of organizing data for analysis. We're going to start with data concepts and graph summaries. So we're just going to look at ways to kind of quantify or qualify our data into certain categories. So a couple definitions. First off, numerical or quantitative data. So quantitative, think of quantity. We're thinking of numbers. We're working with things that are going to be very specific to counting and things like that. In terms of the word continuous, if data is continuous, then it's a range of values where any value can be used. This would include decimals and things like that. And so we illustrate this with a bar graph, or a histogram, where the bars are touching. So an example of this might be the class tracking individual calorie intake for a day, and we might have a range of values from 1,500 to 3,000 calories. So we could have any number within those ranges, and it's not idealistic to say, okay, each individual count of calories, 1,651 calories is one column, 1,652 calories is another column. We put them in ranges. Discrete data is when they can only take those specific values, and then we can easily count them. So bars are used separately on the histogram. So a class tracking the number of ways that or the number of siblings each student had. So you can have things like 0, 1, 2, 3. So here's examples of continuous and discrete graphs. Or a continuous graph, we are in these ranges. Each bar is representing about 250 calories, so 1,500 to 1,750, and so on. And so there is our breakdown for this class and frequency. Here, counting the number of siblings, each bar is illustrated as separate. Now, on top of quantitative data, we have qualitative data, and that's where we're looking at like kind of categorical data, things we can put into categories. So there's two types of categories there. Ordinal data, and that's when we have categories that can be ranked, such as military personnel. We can look at the ranks of like private and corporal and sergeant and lieutenant and general and all what have you. And those ranks go in an order. You then can count how many are in each of those ranks. When it's something that can't be ranked, we would use the term nominal. So we have different categories that we can't rank. Like if we were counting the shapes of marshmallows in a box of Lucky Charms, we have hearts and stars and rainbows. Each of those doesn't take precedence over another. They're just all there, so we can just count how many of each marshmallow type appears in the box. In both cases with categorical data, we're going to show them with separate bars on the histogram because they are countable values. So whenever we can count the values easily and look at every single value as independent, then we would separate those bars on the histogram. Otherwise, if it's one continuous kind of thing, then we're looking at, or if there's a range of values, it's continuous. So we look at an example here. We want to just identify the types of data that were being described in each of the histograms. So if we're looking at the height of sports ball players, we have our height in inches versus the frequency. And so you see here we have bars that are touching. So right away, you should recognize that this is going to be a continuous data set. Counting each individual height is probably not the most realistic of options, where counting how many are in a range of heights is more realistic. So this here would be a numerical value. There's numerical data, and it's continuous. In terms of, I missed a U there, continuous. In terms of the second graph, we're looking at sports ball positions. So these are some different positions in sports ball. There's coaches, other coaches, left coaches, right coaches, and green coaches. They are separated bars. So right away we know this is not continuous data. So we got to look at the options that are available to us. So is this discrete data, where it can only take specific values? So such as if we were tracking the number of siblings in the frequency of the different siblings, 1, 2, or 3, or is a set of categories. And if you look at it, we have coaches, other coaches. These are actually categories versus a number of values. So this is now moving to categorical data. And so then we have a decision: is it ordinal or is it nominal? Do these have a rank or do these not have a rank? Assuming that we're looking at positions in a game, think of a hockey team, think of a football team. Well, you might say, yes, the quarterback is very important. Every position is important to protect that quarterback. So in terms of a sports team, all positions should have an equal ranking. Thus, this would be a categorical and nominal. If there was a hierarchy, if it was coach, assistant coach, but in the terms of sports ball, which is a made-up game, then the different positions that players would have would not be ranked. And now, finally, if we look at a couple of graphs here, just to look at kind of summarizing. The following graphs show the number of tweets at various times over a 36-hour period for hashtag math, hashtag vacation, and hashtag Junos. Junos being Canadian awards ceremony. So our first graph here shows math and vacation in red and blue, respectively. If you take a look at the values, they're going up and down, peaking and dropping at different times. And then in the second graph, we have the Junos, which are relatively low and then peaking and dropping. But do note a difference in scale. This first paragraph goes to a peak of less than 200. This second paragraph peaks at around maybe 11,000 tweets. So there's quite a difference in the number of tweets that are happening here. So first question, what do these graphs tell you about the frequency of each type of tweets? Well, hashtag math and hashtag vacation go up and down. During the day. But are relatively low. Hashtag Junos is limited until about 6 p.m. where it spikes until 12 a.m. No, p.m. 12 a.m. Middle of the night is 12 a.m. So that's a basic description of it, and we can kind of see those patterns. The second part then says, are the graphs comparable? So if we look at them and say, well, is math and vacation comparable to the Junos? Are they really comparable? No. Math and vacation are going anywhere from almost zero in terms of math at midnight, and then peaking, at noon, and then peaking during the early evening, and then vacation is dropping down to maybe 20, but neither is getting higher than 180ish. So neither of these are really that high. Where if we compare down here, if this is 8,000, this is 4,000. This is 2,000, 1,000 would be here. This is still probably higher throughout most of the day. This is probably around dropping down to maybe, 250, 200. It's still probably higher throughout the day than the actual Junos, than the math and vacation, and then it drastically jumps significantly higher. So no, these graphs would not be comparable in this case. All right, that's it for this one. So again, quantitative data being that numerical data, continuous and discrete, and then qualitative data being ranked into categories are the big concepts here. So how do you organize your data and then put them on the graphing situations.